Welcome back. We were discussing in Fundamental of Electronics the special purpose diodes. We will see in this lecture the first important type of special purpose diode, that is the light emitting diodes. Before that, we have also discussed the linear diodes. What are optoelectronics devices? Optoelectronic devices are those devices which combine the principle of optics means light, and the fundamental of electronics. So you will be having the combination of optics and electronics, and that will give you the device which is known as optoelectronic devices. The device, for example, the LEDs, which is the light emitting diodes, the photodiodes, optocouplers, and the laser diodes comes under the category of optoelectronic devices. If we talk about the function of the LEDs, they convert the electrical energy into light using the principle which is known as electroluminescence. When the diode is forward biased, electrons will cross the PN junction and they will release energy as photons in the form of light. So we are required to put the diode in the forward bias region so that the electrons are crossing the PN junction, and then we get the photons which is in the form of light. The colors of LED depend on the semiconductor material energy band gap. There are different colors. We can get it in the form of red, green, yellow, blue, orange, white, and infrared, which is invisible. The characteristic of LEDs, they are low power LEDs which have longer lifespan, low energy consumption, and faster switching. The common uses are the indicators on the panels, the routers, remote controls in the infrared, etc. If we want to calculate the voltage and the current of the LED, let us take the circuit diagram where the power supply is giving a voltage Vs, and the LED which is emitting the light, the LEDs which are emitting the light, and it is shown by two arrows. So the current which is coming from the source and flowing through the resistance is given by Is is equal to the difference of the voltage of the source and the LED voltage, which is Vs minus Vd, divided by the resistance of the internal sources, Rs. Typically, the forward voltage drop lies around 1.5 to 2.5 volt at a current of 10 to 50 milliampere. Nominal voltage drop is 2 volt, which is used for analysis or the troubleshooting. We want to control the brightness of the LED. So the luminous intensity, the unit of measurement of luminous intensity is basically the candelas. The smaller unit is millicandela. Let us take an example of a red LED. The number which we get it is in the form of TLD R5400. This is the manufacturer number. So the red LED has a forward voltage of 1.8 volt and an intensity of 70 millicandela at a current of 20 milliampere. So the intensity will drop to 3 millicandela at 1 milliampere. So if you are reducing the current from 20 to 1 milliampere, the intensity, that is the brightness, also reduces from 70 to 3 millicandela. If you talk about the voltage difference, if the source voltage is very, very high than the diode voltage, then the LED brightness remains constant. And if the source and diode voltage are approximately equal, the brightness varies noticeably. So we need to keep the brightness constant, so the source voltage has to be greater than the diode voltage. The best method what can be used in practice is use a current source to drive the LED for constant brightness. So we should use a current source, then we get a constant brightness. Other optoelectronic devices beyond LEDs, if we talk about, they also use the photonic action of the PN junction. These devices source, detect, and control the light in various other applications. For example, we will start with the 7-segment display. If we talk about the structure of 7-segment display, we will have 7 rectangular LEDs, the numbered from A to G. So here we can see the numbers A, B, C, and so on till G we have. So 7 segments are there. These are a representation of the LEDs which are connected in the form of a rectangle, and these segment forms part of a digit or a letter. So we can see here the 8 is being shown as a rectangular, So when the LEDs are on, either 1 or 2, it will represent a different numbers. So the electric circuit or the electronic circuit of these LEDs, which is the schematic diagram, is in the front of 7 LEDs, which are light emitting diodes with a resistor which is in series to each LED. And there are 7 numbers. So these segments will be connected to form different digits, whatever we get it from 0 to 9. This is the actual display with the decimal point for the device. If you talk about the operation of this 7 segment display, by grounding the specific element, different digits we can get 0 to 9 with the use of the letters A to F can be displayed. So we can either want to get the letters or want to get the digits. Both can be possible with this 7 segment display. For example, if you want the grounding segment ABC, display the digit 7. If you want to grounding segment ABCD and G, display the digit 3. So we can get different letters as well as different digits. The other category of optoelectronic devices is basically the photodiode. If we talk about the operation of the photodiode, in reverse bias, the photodiode detects the light. So it is not the forward bias, but the reverse bias where this photodiode will be detecting the light. So the incoming light will dislodge the valence electrons, that is the electron present in the final orbit, and it will generate the free electrons and the holes. The stronger the light, the larger the reverse current. So whatever the input light you have, it is how stronger the brightness or the intensity, you will have more reverse current. The key characteristic, if we discuss, then they are light sensitive, their reverse current increases with light intensity, and typical reverse current is in the tens of microamperes. The semantic symbol of the photodiode, you can see here, the direction of the light is incoming to the diode. So incoming light is shown by incoming arrows, whereas the previous one, whatever we discussed, the LEDs, it was having outgoing arrows. So there the light was outward. Here light is inward. Other important special purpose diode is the optocoupler or the optoisolator. It is formed by the combination of LEDs on the input side and photodiode on the output side. So you will be having the combination of LED that is on the input side, and you will have the photodiode on the output side. So you are having the source V1 and a resistance in series R1. Similarly, output you have the voltage V2 and you have the resistance R2. So the photodiode will have a reverse biased operation. If we talk about this circuit, then the input voltage, which is V1, will drive the LED. So here you have the LED which is emitting the light. So the light will be emitted. The photodiode will detect the light and create a reverse current. So this photodiode, which is taking the incoming light, it will create the reverse current. This reverse current will generate a voltage across an output resistor with the output voltage varying with the input. So you will be getting the output voltage V2 depending upon what is the input voltage V1 you are giving for the LED. Applications of these optocouplers provide electrical isolation between the input and the output circuit. It is useful in high voltage applications where circuit potentials may differ by several thousand volts. Other variants of this optocoupler we can use as phototransistors, photothyristors, or other photo devices for the output voltage. Other important category of these optocoupler diodes, we have the laser diodes. Lasers, on the aspect of coherent light, unlike LEDs, these emit coherent light with light waves in the phase. So they are not like LEDs, they are basically emitting the coherent light. How it works? It uses a mirrored resonant chamber to reinforce the light waves at a single frequency and produce a narrow beam of intense, focused and the pure light. If we talk about the types, it will be produce the visible light as red, green, blue, or invisible infrared light. The application of laser diodes is in the telecommunications, broadband communication using fiber optic cables, the consumer electronics like CD, DVD players, laser printers, medical, aerospace, defense, industrial systems, and many other applications in machine vision systems, sensors, and the security systems. We have discussed these special purpose photo or optocoupler laser diodes in very brief, giving you the overview of their basic principle. Next lecture, we will discuss the Schottky diodes as other special purpose diode. Thank you for now. See you in the next lecture.